And this is the Mechanics Homework Booklet question 41. We're told an e-bike is a bicycle that's assisted by an electric motor, and the figure below shows an e-bike and rider with a total mass of 83 kilograms moving up an incline. Immediate thought, am I going to be doing components? No, actually, doesn't look like I am. So the cyclist begins at rest at A and accelerates uniformly to a speed of 6.7 metres per second at B, and we're given a distance between A and B, and we're asked to calculate the time taken for the cyclist to travel that distance. So I've got a final velocity, I've got an initial velocity, I've got a displacement, and I want a time. If I think that through, check out my SUVAT equations. I've got a constant acceleration, yes, accelerates uniformly, big look SUVAT. S equals a half U plus VT, U 0. I can rearrange that very easily by multiplying each side by 2, dividing by V. T is 2S upon V. Lob the numbers in and end up with 14.93, or two significant figures, 15 meters per second. What am I talking about? 15 seconds. Why is this misbehaving? There we go, 15 seconds. Calculate the kinetic energy of the e-bike rider when at B, giving your answer to an appropriate number of significant figures. This is a straightforward EK equals a half mv squared, half times the mass times the final velocity. Those both came from the data we were given in the question. There's the mass, there's the final velocity, and I get, when I do that, 1862.9 joules. An appropriate number of significant figures, well, both those bits of data are to 2 significant figures, so I'll give my answer to 2 significant figures. If I wanted to be absolutely sure, I could have given it as 1.9 times 10 to the 3, because of course 1900 is a little ambiguous whether that's 2, 3 or 4 significant figures. But 1900 joules. We're then asked to calculate the gravitational potential energy gained by the e-bike and ride between A and B. Again, we've got that mass times g and the height change, 3 meters, sorry, calculates to that, and again to 2 significant figures, 2400 joules. Between A and B, the work done by the electric motor is 3700 joules, and the work done by the cyclist pedalling is 5300 joules. We're asked to calculate the wasted energy as the cyclist travels from A to B. Well, if I want to calculate the wasted energy, in this case what I'm going to have to do is calculate the total energy that was input, so those two values from this part of the question added up to 9000 joules. Calculate the total useful energy output, the kinetic energy, and no, that one's the potential energy, and the kinetic energy. That gives me a total energy output. The wasted energy will be the input, take away the useful energy output, gives me that, 4700 joules. Finally then, I'm asked to state 2 causes of this wasted energy. Air resistance, or drag, is going to cause it, and friction. Now, whenever you talk about friction, it's important to talk about where that is. So friction in the wheel bearings would be appropriate, friction in the chain would be, friction between the wheel and the road would be appropriate. They didn't want friction within the motor, because that would come off, any work that did would come off before the power output of the motor, which is what you were given. It's likewise not energy losses within the cyclist, the cyclist heating up. Not heat, because that's not a cause of the wasted energy, it's a form of energy the energy would end up in. And again, sound. Sound is generally just so small compared with any other losses that it's not usually an accepted answer, so be inclined to steer away from sound. So that's the Mechanics Homework Booklet question 41.